All right, let's talk about what makes up an atom in terms of its protons and neutrons, kind of gives it its identity. And to do that, we're going to talk about this little guy up here. So if you imagine here, it's written as an X, but if I write an atomic symbol, which is, one or two letter code, C for carbon, Ne for neon, etc., anything you'd see on a periodic table, if I write that, that tells me what chemical I'm talking about, or sorry, what element I'm talking about. And then the common notation that we're going to be using is we attach these two numbers to it. Now, sometimes we write both numbers, sometimes we write no numbers, other times we write one of them. Some of them are redundant even, but we put these two numbers. I know they're written as A and Z here, which is again confusing, but A is the variable that stands for the mass number. Okay, the mass number tells you how many particles, protons and neutrons, are in the nucleus of the atom, and that's going to tell us a relative mass, kind of a close approximation of the mass of that element. And then Z tells us the number of just protons in the nucleus, and that tells you the identity of the element. So this is redundant with the atomic symbol, and I'll tell you what that means in just a second. Let me switch over to my whiteboard. And we're going to start out with sodium. Now, sodium's got the elemental symbol Na, right? More confusion. There's no S in sodium's elemental symbol. So Na, and if I put in here 11 and 23, we can talk about what these numbers mean. So again, 23 is the A value or mass number. Okay, and that tells me I have a total of 23 protons and neutrons in the nucleus. Okay, 11, I'll write in red. 11 is the Z number, which is the atomic number. And that tells me the number of protons in the nucleus of an atom. So here's the crazy part. Sodium is the 11th element on the periodic table. If you guys look, right, so you can go through hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You get the sodium. Sodium is the 11th element. So these two pieces of information kind of tell you the same thing. The number of protons in an element determines its identity. So you can say the atomic number is the identity. So really when we write sodium, we mean 11 protons, okay? And then you guys can see the 23, which is the sum of the protons and the neutrons, can then be determined based on those 11 protons. So I'll draw them here. If I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and I need to get up to 23. I'm going to keep counting. I'm going to switch colors. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So say that this is green as neutrons, red as protons. Well, I've got 23 particles inside that nucleus. Okay, and if together these would have a mass number of 23, but I have 11 protons, well then 23 minus 11, I have to have 12 neutrons, right, to make that mass number of 23. So that's the nucleus of a sodium atom, okay, with a mass number of 23. It's got 11 protons and 12 neutrons. Now, from here, we can also talk electrons, since we're going to stick with neutral atoms. Protons have a positive charge, which you guys hopefully remember from physical science, and electrons carry a negative charge. Okay, so electrons, we're going to later find out, they are located outside of the nucleus, away from the protons and neutrons. They also exist in what are called orbitals, but for now, we're just going to put them on the outside. They're also much, much smaller. Okay, and we're going to assume that all the atoms we talk about for this unit, at least I'd say most of them, have no charge, or we say are neutral. Okay? Neutral meaning so that the protons and the electrons are equal in number, so they cancel each other out. 23 positives, 11 positives, 11 negatives will cancel each other out. So if I put my electrons as little gray little dots, I'd put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, you notice I'm going to just draw them outside of the nucleus for now. I know that you may have seen them in Bohr models where we put them in little rings around the nucleus. That's not necessarily the best model, and not the model that Willamette Promise wants us to teach. So for now, we're just going to put them on the outside. So that sodium atom has 23 total particles in the nucleus, 11 protons, 12 neutrons. And to keep it neutral, outside the nucleus, it has 11 electrons. Okay, we could look at some more examples. Let's say, let me look at my periodic table. Let's give you two isotopes of copper. What's an isotope? Well, an isotope is an element, or like two atoms of an element, that might have slightly different mass numbers, but they're still the same element. So copper 63 and 65 have different mass numbers. One's heavy, one's light, but they're both copper. Now, to figure out the rest of the symbol and protons, neutrons, and electrons, I'm going to make a little table. Okay, we can look at this. Well, we look up element copper. Copper is a transition metal in the middle of the periodic table, right? Copper is element number 29. So right away, if it asks about atomic number, you know 29 and 29. That's consistent, right? Because they're both copper. Then you talk neutrons. Well, neutrons have to be the sum of the protons, or sorry, the neutrons have to make the mass number when you combine them with the protons. So I can subtract 63 minus 29 would be 34. And 65 minus 29 would be 30, what would that we say, 36? And you guys can see this one is 2 units heavier, the second one. It's 2 units heavier because it's got 2 extra neutrons. Okay, and then again, we're kind of going to gloss over the electrons. But the electrons, to keep it neutral, right, a charge of 0, we would have to have the same number as our protons. Okay, I could have done something a little different. I could have said, like, say, how about this? Instead of having a neutral charge, if I say it has like a 2+ charge, well, then it could be 29 protons, what are we, 34 neutrons, and then this time 27 electrons. And that would mean it's got a charge. If I have 27 positives or 29 positives and 27 negatives, overall that would add up to a +2 charge. This is called an ion. So ions have non-zero charges. But right now we're going to focus more on isotopes. We're going to ignore this number up in the upper right. Again, we're focusing only on mass number and atomic number. Okay, but I know I'm talking electrons. I don't want you to just think they're unimportant. They're just not quite, we're not quite to them yet. Let's see, what else can we talk about? I think that's, let's say identify, let me give you one. Identify this element, let's say write the chemical symbol for this and use proper notation. So we already know A to Z, top to bottom. You can go there, but my question is, what symbol? Well, you look up 17, and that's going to tell us something. So you find the 17th element. So chlorine, which is on the right side of the periodic table, we're going to later call those it's in the P block, and it's a non-metal. So we can differentiate metals and non-metals, and we say that this is on the right side of the periodic table. So chlorine is the 17th element. And I should point out, in chemistry, I'm going to write my L's in cursive because it can get pretty confusing if I write that. Is that a 1? Or is that a lowercase l? I don't know. Is that some straight line? So my L's, when I'm talking elemental symbols, will be written in cursive so you guys can tell. So that's element chlorine. How many protons, neutrons, and electrons does it have? Well, protons got 17. Neutrons and protons have to sum to make 37. So I think 20 plus 17 makes 37. And then electrons have to cancel out the protons. So there we go. I think that's a good place to stop the video. You guys should be able to identify those numbers and work through some problems with those.